Hello there, and welcome to the second video for the NVIDIA Omniverse Basic Training. This training comes after the NVIDIA Omniverse Introduction Training, which as of today, April 25, we have 6 videos in the first one. So in this second lesson, we are going to be using USDExplorer, and you will have a hint of what looks like a final delivery for an end user. We will have a high-level view of the structure of a USD file and how do we reference other USD files within one USD file. And then we will have hands-on on the next extensions. Most of them are available by default with the installation of your USDExplorer application. But for example, the variant presenter extension, we will have to add it manually. This first extension allow us to play around with all available variants in our file. And then the measure extension will allow us to get real measures within different points in our scene, in our state. The markup extension will allow us to put manual markups in our scene, even in a 3D environment. The Waypoint extension will allow us to set up several views, several cameras around our scene. The section extension will allow us to cut a plane of our project, of our scene, and you can move the plane so you can see a section of your project, like cutting it in half. And then finally we will do a very small exercise simulating how physics works and how do we set up physics in our Omniverse application, in this case USDExplorer. So without further ado, let's go for it. Okay, first thing we are going to do is to launch our USDExplorer application, like that. In the meantime, I have downloaded the assets that we're going to use in this lesson. I'm sharing the link for these assets in the description of the video. Let's unzip it if I can. Okay. Now let's go back to our application, click new, navigate to the assets that you just downloaded and open Factory Light USD. Now don't save. To develop a digital twin, we need to aggregate different type of data from different sources. Let's see how openUSD can help with that. Let's go and save this Factory Light USD as USDA, which is human readable language. Save it. Then go and open it with VS Code or any other text editor. So we have it here. If you see, they use this binary code, so you cannot read it. But USDA contains the same information, but in ASCII code. So this file is defining all our state, which will include 3D assets, materials, lights, physics, actions, everything. But if we define all that in the same file, this file would become too heavy, will become massive. So to make it easier, we are referencing other files. For example, search for vehicle hanger adjust. Anything that has a def in the front is a reference to an asset, and we are using the payload to make it available or not. We can choose to load it or not in our factory light file. Then let's have a look to the vehicle hanger adjust USD file to see what we are referencing. Go to the folder sub USDs, look for vehicle hanger adjust, open it. We need to save it as USDA as well. Save it and go back to VS Code. Let's open it. Okay, so this file contains another reference to the vehicle hanger adjust. So I created the USDA for, no, sorry, this is how do we name it, because we have a layer here. So let's look here for export. As you can see, the USD file vehicle hanger adjust has another reference to vehicle hanger export. So now let's go and open the export one, and if you go down, this is the all the how do we build the 3D asset with all the vertices and structure. Okay, imagine having all these per each asset in our project. So instead of doing that, we are just referencing to this. When we are doing references, take note that any change that you do here, it will be reflected as well in the factory light in the factory light file. Let's go back to our factory light file and now search for variants. Here we are defining different variants for one of the USD files that we are referencing. To see how these variants work, let's add a new extension to our USD extension application, which is variants presenter. So let's go back to the, you will need to close the application first, the Kit application. Go to your Explorer application, Kit file, and I didn't close my application because I'm not sure if I already have this extension. Okay, I don't have it, so I'm going to close the application, don't save, and I'm going just to add this new extension in my dependencies. like that. Save the file, build it, and we launch it again. New. Let's go and open our factory light. Now in Windows we have, no, in Tools we have, before we added this extension we didn't have this variant extension here, but now we have it. So we go to OK, variant presenter is opened here. Now we have all the variants that we have defined in our USD file. This is for reading options. So if you change the variants, you can see we are adding the readings here. We can add a fence, and we can change colors for the painting in the floor. That's how variants work. End users of your application will import 3D data from various sources. Let's give an example with some of the assets that are out of the box available in NVIDIA. Let's go for open the warehouse folder to make this a bit smaller. Let's pick one of these assets. It will automatically drop into the floor. You select the asset, click F to center it. If you see, if we set the Z in 0, it's because the origin of coordinates is set as in 0, like in the basic plane of the scene, same as the floor. Now there are different ways to duplicate assets, like right click, duplicate, or you can just select the asset and set Ctrl D. We are duplicating, but we can do also things by code, and that's useful in case that we want to create some behavior or automatize some actions by code. So let's save this file. We are in the USDA. Now let's navigate to VS Code. Not that one. That one. Now let's look for containers. So this is the asset that we just created. So if we copy paste all this code, all this definition, know that all these assets are also references to the folder of NVIDIA. We have to change the name, container, for example. And we are going to move it already a little bit in the X. I'm going to move it to 500, for example, and 500. Now if I save it, instantly in our scene, we need to click fetch first, and here's our new container, container by Borja. Now we are going to see how do we use measure extension to measure distance between points. To do so, first we are going to open one example from NVIDIA factory. Double click on it. As you can see, this example has already some measures on place, but we are going to measure to see how do we use them. In the stage, search for road pedestal, click enter, and then select that one. Click F to navigate to it. With Alt button clicked, we can rotate. Okay, so we are going to add the measure between this point and this point. We go to Tools and click Measure. This is an error in this extension. Okay, this is an error for the extension that probably NVIDIA will fix soon, I hope. But if we go to Review, here we have also the measure option. See? Click left vertex selected, and that's going to add a point. Custom perpendicular vertex. One second. Point to point. Custom. Yeah. Sorry, because I had already selected something here. And now this selected. Okay, it's because it's not detecting the edge vertex. Something is not right. And now, okay. The problem that I was having is because, yeah, I had this asset in front of me, so I couldn't reach the pedestrian. But if now we can make different measures between different vertex, between different corners. Let's go and save this with a different name. To save it as USDA. Okay, so that's how we use the measure extension. I will keep an eye on the error that we are seeing here because I'm not sure what is this about. In Visual Code we have also the errors or the commands that we are executing in our application. Now we are going to see how to use the markup extension. As we just saw, in review mode includes a navigation bar at the bottom center of the screen, which can be turned on and off with this button here. Click the markup button to open the markup panel. Then let's go to add a new markup. We can draw on top of the markup and we can write a comment. Let's do it in blue. No, not this, the comment. My comment. Apply. And now we can select our new markup here, like the others that we already have by default. One thing we can do as well is to export the markup as these formats. So let's go and try the PDF. That's to create reports or whatever use case that you can find out. Now we have it here. Normally, the layout view is the kind of view, the kind of final application that we will be delivering to our customer. And that's all for markups. Now let's have a look to the Waypoint extension. This is like Let's close that one. This is like different point of views in your scene. You can click directly in the blue points and you will get like different camera views from each one. You can also click the views from here, and let's go in, and to create one new waypoint is as easy as select the view that you want. So put the camera in the position that you want, then just click add waypoint, and now we have the waypoint that we just saved. Easy peasy. One more cool extension that we have here is the section tool. Let's go, you go to the exterior or anywhere, you click the section, it will appear the section. Basically, let's move this away. We are cutting the view of the factory in this plane. If you move the section up and down, you can see that we are cutting the section. You can choose to rotate the section any kind of degrees, for example 10 degrees, and you will see the section like that. You can rotate a little more. You can choose the section. How do you want to cut it? And that's it for sections. Digital twins can simulate real-world behavior based on physics. That's the best part of it. This lesson is not to learn how to use physics, but to see how do we execute the play extension in our USDExplorer application. We are going to do a little bit quick lab, a little exercise. But before that, we need to enable physics in our application. To do that, go to your Explorer Kit application. I want to be sure that we don't have this enabled here. Okay, I already added this at some point, but probably you will not have it. It's not this dependency, this extension is not here by default. So we just need to add this extension to enable physics. And then we have to, let me find, this use fabric scene delegate is set as true by default. We need to set it to false because it is incompatible with our physics extensions bundle. This fabric is a part of the USD real-time library. This is useful to speed up interaction with a USD state, but this will not allow us to execute our physics. So let's save the file. You need to build it. Then we launch our application. No. Let's go and open our factory light. I'm going to remove these assets. So let's do some example really quick. Let's pick a conveyor. Conveyor belt. Let's put some boxes on top of it. I'm going to save. Where are the boxes? How they ended here? Save. So now if you click play, nothing happens because we didn't add the physics to our assets yet. So now let's go to add the physics to our assets. We add the physics to the card boxes, right button, add physics. We add a rigid body with colliders. So the rigid body will allow the assets to be susceptible to gravitation and other forces, and the colliders will make them collide with other objects that also has colliders. In the conveyor we are going to add collider only to the belt. And now we are going to enable the kinematics because we are going to simulate the movement of the conveyor. We allow velocities in local space, and we are going to add physics surface velocity. This is only to show you how we use the physics here in USDExplorer, but we will have another lesson where we will dig deeper in physics. So now I added the surface. Where is it? That one. And in the epsilon, we are going to add, this is 20 meters per second, I believe. And now, in theory, if I click play, I'm going to save it first. If you want to restart the scene from the beginning, you need to save the original position, because once we click play and things start moving around, you will not be able to restart it. You can do that in USD Composer, but not in USDExplorer. So now you can see we are simulating gravity. The floor, by default, with the assets that we imported, the floor already have colliders. That's why we are not sending the boxes to the infinite. Okay, I'm going to open again the file. So basically, once we finish our project, this is the kind of application that we would give to our end user, to our customer. Also depending of the final use case, but you can have an idea. So they can simulate here whatever they want, and ideally, depending on the use case again, but at some point we can also connect our digital twin to the real thing. So we could be seeing here exactly what is happening in our factory. And that's all for this lesson. See you in the next one.